Okay, so recording is starting. So welcome from YouTube. We have a lot of viewers actually, I realized, so that's quite good, I would say, for like quantum foundation seminars. We reach even like 60, 70 views, which is astonishing. So, okay, very welcome. I'm very happy to introduce Vera Matarese, who's a colleague, philosopher of physics from University of Bern. She's doing a postdoc. She's going to speak about quantum Humeanism or quantum Humean fictionalism.
Yeah.
So whenever you want.
Thank you so much, Christian, for inviting me, for organizing this, and thanks to all of you for coming. So yes, today I would like to talk about a strategy that has been proposed to solve the problem of the incompatibility between Humeanism, which is a metaphysical view, and quantum mechanics of a physical theory. And this strategy has been named quantum Humeanism. But as I will hopefully show in this talk, I have some reservations about quantum Humeanism, and so I will propose my own view, which is quantum Humean fictionalism, which is not really a view that I personally endorse, but a view that I suggest and offer to the philosophers who endorse Humeanism. So as a kind of introduction, since I think most of you work in physics, this is what I'm trying to do. So on one hand, in the metaphysics, we have this metaphysical view called Humean supervenience thesis, but for short, we will just call it Humeanism. And then in physics, we have this physical theory called quantum mechanics, okay? And then they both are very powerful theories in their respective field. So Humeanism is a very powerful metaphysical view in metaphysics because it can account for actually every kind of phenomena, or in any case aspires to account for every kind of phenomena with a very parsimonious and common sense ontology. So it postulates the existence of point-like objects with intrinsic properties like mass and charge and other things. On the other hand, we have quantum mechanics, which is a very powerful physical theory because it can predict and it can explain even weird phenomena like the double slit experiments. And so as a philosopher of science, as a metaphysician of science, my question is, but are these two theories compatible? And if so, how? And you see, like the most important problem for this compatibility is that Humeanism presents us with a local world, which means we have different entities in the world and they are all located, and each entity has its own property. And we can have a description of the state in terms of these point-like objects and their intrinsic properties. We don't need more. While quantum mechanics has some non-local features like entanglement, entangled states like the triplet and the singlet states. So how can we find these two views compatible? And actually, I would like to stress not only the fact that this question is legitimate, but also that it's important. Why? Well, because Humeanism was born as a theory whose truth actually was decided in light of physics. Indeed, the father of Humeanism, David Lewis, was saying, well, it might be the case that physics tells me that my theory is false. And if this is happen, I wouldn't grieve. And this might indeed happen. Maybe the lessons of Bell's theorem is exactly that. And we know now that Bell's theorem actually tells us that we should take non-locality very serious. And so in front of the Bell's theorem, should we really then say that Humeanism fails and that it's a false metaphysical theory? The second reason why I think that this question is important is that quantum mechanics still needs a very clear metaphysical account of what exists in the world. Okay, so we are still debating about which parts of quantum mechanics formalism is just a calculation device, or which part actually is representational accurate because it represents something that existed there in the ontology. And so in order to solve this kind of apparent incompatibility, then three different proposals have been offered in the literature by philosophers. And then, so one solution will be to say, well, look, we are sorry, but Humeanism has to take non-locality seriously and has to put locality in the ontology, and we call the ontology the mosaic, because this is how Humeans call this. But this, of course, would contradict one of the central tenets of Humeanism, so it's not really an optimal strategy. The second would be to say, well, look, okay, quantum mechanics tells us that non-locality exists, it's in our ontology, but we can still say that it supervenes, which means that it exists at a kind of emergent level, not in our fundamental ontology. But then the problem is that if we want to do this, then we have to assume that we live in a very high dimensional space. So this is, for instance, what Lower and Albert kind of agrees with. But for the Humeans, actually, supposing that we live in a very high dimensional space, actually it's a very high cost, because one of the most important qualities of a Humeanism is to have a mosaic, a fundamental ontology, which is extremely intuitive with common sense. So we can say that it's a very intuitive ontology, and then saying that we live in a high dimensional space is not intuitive anymore. So then the third kind of strategy would be to say, well, look, but we can say that non-locality does not belong to the ontology, so what exists in the world, but it belongs to what? To the laws. So actually, when we talk about entanglement, features in the description of our state, quantum state. How? Well, in the form of an entangled wave function, and our entangled wave function figures in laws. For instance, the Schrödinger equation, okay? But then this kind of entangled wave function is not part of our world, it's part of the law. And this normally is regarded as the best solution for Humeanism. So in this talk, I would like to focus on this third strategy, and in particular, one particular strategy, which is called quantum Humeanism and was developed by Esveld in 2014. And it was really born to solve the incompatibility problem, but now it's being incorporated in a far-reaching view, super-Humeanism, that aims to actually give an ontological account to different physical theories and not only quantum mechanics. So why am I focusing on this particular account? Well, I'm focusing on this particular account because I think it's particularly rich. It has been developed through many years. There has been many papers. Actually, Esveld uses many different metaphysical conceptual tools like the best system account, functionalism, identity reductionism, entailment, nomological or primitive ontology. And so these are all kind of elements that it grabs from other literature. And I think it's very interesting to see how they all play together. And I think it's quite interesting to check whether they can actually form a coherent view. And in this regard, I have some perplexities, because I think that the interplay of these different metaphysical conceptual tools makes the view with some tensions, not really coherent. And so I will try to make it more robust. And by doing so, I will propose a new view, which hopefully can be more appealing for Humeans, which is quantum Humean fictionalism. So what's the plan for today? Well, first of all, I will tell you what the problem is. And so really we'll go into the details about the incompatibility between Humeanism and quantum mechanics. Then I will be talking about quantum Humeanism as a solution to this problem, some challenges, and finally my view, quantum Humean fictionalism. So what is the problem here? So the problem here is that on one hand, we said we have the Humeans, okay? And then the Humeans endorse that the fundamental ontology, which is called the Humean mosaic, is local. What does it mean that it's local? It means that it obeys two different principles. So the first is called the separability principle, which means that the complete physical state of the world is determined by, supervenes on, the intrinsic physical state of each space-time point or each point-like objects and the spatio-temporal relations between these points. What does it mean, this principle? It means that according to the Humeans, the fundamental ontology is just an arrangement of intrinsic properties which are actually instantiated by point-like objects or space-time points. And then the complete physical state of the world is actually determined by these arrangements of intrinsic properties. The second principle, in order to have a Humean local mosaic, is that all facts about the world, including modal and homological facts, which means the facts about our laws of nature, about what's necessary or what's possible in this world, are actually determined by its total physical state. And when I say that, when I use the notion of supervenience, I just mean that if A supervenes on B, then any change in A must correspond to a change in B. So there cannot be A changes without being changes, okay? So there cannot be changes in our complete description of the universe without changes in actually the local mosaic, and so the fundamental ontology of our world.
Vera?
Yeah.
Do you mind? There is a clarificatory question.
Yeah, no. Yes.
Yeah.
Nicholas.
Sorry, just quickly. So on the previous, or even two previous slides, so my understanding is so that what I would call Newtonian non-locality, the fact that if you move a mass in the universe, it has an immediate effect everywhere. This would not be a problem for humanism. And also, the violation of Bell inequality is not a problem. The problem seems to be only entanglement or non-separability, as you call it.
Yeah, so maybe I will be curious to see how you kind of, because normally we relate the Bell's theorem with entanglement or non-local relations as philosophers, but maybe you have a different interpretation of the Bell's theorem. And so, yeah, I will be curious, to hear maybe in the discussion or.
And what about Newtonian non-locality?
Yeah, Newtonian non-locality is not a problem.
Because it is separable.
Because you can describe everything with just the properties, the intrinsic properties of the single objects and spatio-temporal relations. Yeah, you're right.
Although you can violate, of course, CHSA, Bell inequalities with Newtonian theory.
I see. Okay. Yeah, I see.
Thank you. Sorry, I don't want to interrupt more. Thank you.
Yeah, no, I'm very interested. So we can discuss this. Yeah, thank you. Thanks. Good. Yeah, Christian, tell me if there are clarificatory questions because I don't see. Yeah, thanks.
I will. Thank you.
Yeah, thanks. Good. So then we have entanglement. So we have quantum mechanics. So we say, okay, on one hand, we have Humeanism. Now we have a quantum theory, and quantum theory tells us about the existence of entangled states like the singlet and the triplet states. So since you're physicists, this are better than me, but of course, these entangled states really tells us about the presence of some form of non-locality. So we have 50% of probabilities to find a state in which electron A is in up spin along the z direction, and electron B in the down spin direction, z direction, and 50% of probability vice versa, right? That actually the electron A is down and the electron B is up. And so we know that if we find electron A up, we know automatically that the electron B will be down and vice versa. So this kind of non-local features and this kind of entangled states, which are expressed with this entangled wave functions, is really what worries the Humeans. So there is actually a way to solve Humeanism, and it would actually be to claim that, look, these entangled states, this entangled wave function, the singlet and the triplet states, actually supervene on the intrinsic states of the electron. What does it mean, supervene? That they are determined by the intrinsic states of the two electrons. And so really the challenge for Humeans is to provide a descriptions of the intrinsic state of the electrons such a way that the entangled states supervene on these intrinsic descriptions of the electrons. Okay, so once we provide these descriptions, then we can say that actually Humeanism is saved. But here it's what's the problem, because how can we actually reduce the entangled states into a descriptions of the single individuals, of the single states of the two electrons? Well, we have two options, but it seems that both options are not really working well. Why? Well, because if we try to attribute pure states to the individual states, then we would violate the empirical predictivity of quantum mechanics, because we would not be able to recover the probabilities of the entangled states. And so we cannot use pure states. So then the alternative is to use mixed or impure states, okay? And this would work well, probabilities would be recovered. But the problem is that we would have to assign the same intrinsic states to both the singlet and triplet states. And this is a violation of supervenience. Why is it so? Well, so why is it that attributing impure mixed states would violate supervenience? Well, we said that for supervenience, if A supervenes on B, any change in A must correspond to a change in B. But if we attribute the very same intrinsic states to both the singlet and the triplet states, we violate this. And this is because the triplet and the singlet states manifest identical relations only along the z direction. But when we measure the entangled states along the x direction, for instance, then we would find that actually the entanglement relations are different, because they would be perfectly anti-correlated for the singlet states, but perfectly correlated for the triplet states. And this is a problem. So we have two states, the singlet and the triplet, which are different. And then the only way we can attribute some specific intrinsic states is violates the supervenience relations, because it would not it will be the same regardless whether it's actually singlet or triplet. So here is the problem. Quantum mechanics tells us, look, Humeans, your world is non-local. But then Humeanism says, oh, but look, non-locality cannot be fundamental because our mosaic is local. So what should we do? I mean, maybe non-locality can supervene, but no, we said, no, we cannot say that non-locality supervenes. And so it seems that Humeanism really cannot accommodate entanglement relations, entangled states, entangled wave functions. So now we will try to look into this strategy, which is quantum Humeanism. So quantum Humeanism has been developed, as I said, to solve this problem. And the very first thing that Michael Asfeld said is, look, but this supervenience relation is on the entire space-time. So you should not really think that you have to be able to reduce the entangled wave functions at time t1 to the kind of intrinsic states of the electrons at time t1. And then he said, okay, suppose, because he assumes this, that the spin properties is reducible to trajectories. Why? Well, because when we measure spin, actually, the way we can know whether a spin is up and down, it's through the kind of trajectory, as it depends on where the electron ends up with. So where, you know, in which part of my experimental device ends up. And so he says, well, look, the wave function, the entangled wave function, like the entangled triplet or singlet states, actually supervenes on the motion of the trajectories of my electrons from the beginning until the end of the universe. And of course, if the electrons belongs to the singlet state, they will behave differently. So they, in the end of the day, they would have different trajectories than the electrons which belong to the triplet states, okay? Because once then we measure them, not only along the z direction, but also along the x direction, they would end up with different trajectories. And here, the first set of objection comes because, I mean, one might be puzzled about this and might say, well, but look, you know, maybe you can have a very short period of life. Maybe electrons, our electrons have a very short period of life. They might be born at time t0 and then end their life at time t2, right? And then during this very brief span of life, maybe we would just measure them along the z direction, so they would not have the possibility to manifest their diversity, okay? So you could have a world where trajectories of the triplet and singlet states are actually the same because we will never measure them along the x directions. Also, one might say there are cases where you have two different wave functions, but which are perfectly equivalent. For instance, for cases with the global phase shift. In this case, you have exactly the same trajectories, no matter how long the life of your universe is. So even if it's, I don't know, 3 million years, you will still have the very same trajectories. So Michael Asfeld has a response for that. He says, well, but look, the wave function is mathematically spelled out in a certain way. And because of the mathematical language, you might have some kind of mathematical surplus structure. So you might end up with different mathematical wave function, but the difference is just from a mathematical level. But if your wave function map or match to the very same trajectories, then it's because this mathematical wave function actually represents the very same nomological entity called the wave function. And this new nomological entity is a kind of law-like entity. So the wave function is actually a nomological entity, which is in the law of nature, like the Schrödinger equation. And then, of course, you can have different mathematical wave functions that refer to the same nomological entity wave function in case they match the very same trajectories. So then there is another set of objections that Asfeld might have to respond, which, how is it possible that now we are saying that the wave function is a nomological entity? I mean, if you think that laws are nomological entity, then you can think, well, the wave function is an extremely complex entity, but our laws of nature normally are very simple. Our laws of nature are not time dependent, but the wave function is a mathematical object, which is a time dependent. And to this kind of set of objections, Michael has some responses. He says that actually when we say that the wave function is nomological, we don't really mean that it's like a law literally, but that it appears in the laws, because properly speaking, it is in the law, but it's not really nomological like the laws of nature are. So the wave function is nomological just in virtue of being a part of the best system account. What does it mean? Well, it means that when we want to give laws to our theory and that can describe our system, then we normally try to have the laws that best balance simplicity and strength, okay? And so our wave function, of course, is complex, but in any case, it creates a law of nature like the Schrödinger equation, which best balances simplicity and strength. So the Schrödinger equation is the most simple and strong laws that we can have. So as I said before, actually Esfeld puts this kind of answer and response to the compatibility between Humeanism and quantum mechanics in an overall picture of what he calls the Canberra plan, which is actually nothing different in many respects than the primitive ontology program. And Valia is here, and she's one who really, the first who developed this primitive ontology approach. And so according to Néel, actually, the only features of that, you know, of a theory that really we should take seriously are the features that represent the primitive ontology. What does it mean, the primitive ontology? So according to the primitive ontology program, what we have is just point-like particles and their positions and spatial relations. And why is it? Well, Néel argues for this because he thinks that we can see and measure only particle position. So even when we measure mass or we try to measure the wave functions, the only thing that actually we can see and we can measure is particle trajectories, where particles end up with in our experimental devices. So then if we can take seriously from an ontological point of view only this primitive ontology, only these point-like particles, then what about the wave function? The wave function is not in the primitive ontology, there is no ontological commitment. So how can he account for the wave function and everything else that it's not in the primitive ontology? Well, Néel adopts really this conceptual tool, which is the best system of lawhood I told you before. So he thinks that the wave function is just a dynamical parameter which appears in the dynamical structure of the theory, in the sense that it appears in the best system of lawhood for quantum mechanics. It appears in the best possible laws that we can have for quantum mechanics, which means the laws that best really tell us that best balances between simplicity and strength. But then when you ask exactly what is the wave function and what's the relation between the wave function and the primitive ontology, I think that the answer the answers are very conceptually loaded and laden and quite complicated, and sometimes I feel that I feel a bit lost. So first of all, Néel tries to talk about the wave function. So remember, this entangled states that they have no locality in them as one of their features in terms of identity, locations, and the reduction with respect to our primitive ontology. So he says that the wave function can therefore be taken to be located in the motion of matter as defined by the change in the distance relations among featureless point objects. And that he says that the wave function, as everything else that it's not a primitive ontology, is located in the set of the primitive entities in being identical with and in reducing to something in that set. And then its initial values can therefore depend on future motions without any paradox arising. So they are located in the motion as a whole. So he endorses this kind of language, like the wave function is located, the wave function is identical, and I'm not sure if I understand it right. He also endorsed this kind of entailment language. So he says, so the ontology of reductionism, thus spelled out in terms of identity, commits one to the view that the propositions describing the minimal set of entities entail all the true propositions about the world. So if we have all the propositions of this point-like objects, then we will be able to know all the true propositions about the world, including about entanglement relations. And finally, he endorses a functionalism. So he says that the wave function is a dynamical parameter that is introduced through a functional definition that describes its causal or functional role for the behavior of the entities in the primitive ontology. So this is the first role that the wave function has. So it's introduced because of its a causal or functional role to describe, to account, to explain the behavior of the entities. Then there is another functional role that it has, which is the second. The benchmark for the wave function is that it enables the formulation of laws that simplify the representation of the change that occurs in the configuration of matter without losing the information about the change that actually happens, which means, well, the wave function, as we said before, it enables us to have the best formulation of laws in terms of simplicity and strength. So what is the wave function? So according to him, the wave function is a nomological parameter that makes the laws of nature simple, that the wave function is located in the particle trajectories via its functional role, and that the wave function is identical to the particle trajectories. And also, one thing that he stresses is that it's because of this identity and reduction and this functional approach that he can actually recover scientific realism. So what is scientific realism? Well, according to scientific realism, our best theories provides approximately true descriptions about the world, and so we should believe in the truth of our best scientific theory. So as it says, yes, in my laws of nature, I have the wave function, but the wave function can be reduced to particle trajectories, identical to particle trajectories, talks about particle trajectories, so I can believe in my theory. But then I have we are in the kind of like Humean context, where actually Humeans really spent a lot of time talking about laws of nature and how these laws should be formulated. And normally, according to David Lewis, when we spell out our laws of nature, we normally use some predicates, right? Like being a massive, like we saw mass, or being charged, and so charge, and etc. And normally this kind of predicates for Humeans are really those that carve nature at its joints, okay? But then here we have a wave function, which is in the laws of nature within Humeanism, and it's not very clear how we can spell out this wave function in terms of being a predicate in our laws of nature. So we can think of a natural predicates. What does it mean in natural predicates? Well, it means that they really carves nature at its joints. And when we say this in philosophy, we mean that there is really a property in the world which is associated to this predicate, okay? But of course, one cannot be, because Asfeld is very clear that the wave function does not exist in reality. So there is nothing which really corresponds automatically to the wave function. Then the second proposal would be to take the wave function as a kind of uninterpreted predicate, like what Humeans think about chance. So we have this thing, wave function. We have this psi in the Schrödinger equation, but I don't know, what does it mean uninterpreted? It means that it does not have a meaning per se. It's just a kind of mathematical kind of function which is there, which is predictive, which helps me to predict the future motion of the particle, the future evolution of the system, but doesn't have a meaning attached to it, okay? But then since Asfeld also stresses this idea of functionalism, identity and locations, then I mean, I would also be inclined to consider this possibility that we kind of interpret the wave function like a pain. So as a kind of state that is not really fundamental, but that it exists. It's all kind of it's a present, okay, and then it can be reduced to, for instance, some neural state of the brain. So I will try to see 2 and 3 whether actually it makes sense to have 2 or 3 as a kind of account for the wave function. So the wave function should really be paraphrased in terms of particle trajectories, as Néel suggests. Well, if it's so, then the wave functions really represents or refers to some types of particle trajectories. So the wave function is an abbreviation or a kind of high order properties that correspond to some kind of particle trajectory. So it means that when we say that the state has a particular wave function, we actually means that having a particular wave function means having some kind of particle trajectories. But then if so, then there must be a kind of clear correspondence between the wave function and some particle trajectories. And this is a bit challenging for Asfeld because, of course, it's very complicated to really kind of spell out a wave function just in terms of particle trajectories. Should we understand wave function like a pain, as I was suggesting? Well, let's think about like a pain and this neural state C fiber firing. So normally philosophers say, okay, when we say that we are in pain, then we say that actually there is a C fiber firing, which are these fibers in our brain that fire. Then, I mean, normally we say that pain is C fiber firing, and so that the two are identical just because the functional nexus of pain and the functional nexus of C fiber firing are identical. What does it mean? Well, it means that if pain is the effect of Y, but also what causes X, then also C fiber firing in the effect of Y and what causes X. So they are in the same very causal nexus. And so, yes, we can say that the wave function is identical and has the same functions as the particle trajectories. But then, I mean, it's really hard for me to see how actually the wave function and the particles share some kind of same functional nexus, because remember that for Asfeld, the wave function is identical to the whole history of the particles motion. So we have the wave function on one hand, and on the other hand, the whole history of the particles motions. And then we have to try to find a particular causal nexus in which they are both in and in the same position, so to say. And it's difficult to see what this kind of nexus might be. So I think that here, these are the challenges if we really want to say, as Humeans, to say that in the laws we have these predicates, and these predicates have a particular meaning attached to it. Because, of course, for Asfeld, we can't really interpret the wave function as really existing in the world. And so we would need to paraphrase the wave function in terms of particle trajectories. But then what is this functional causal nexus that is for both the wave function and the kind of trajectories? Also, there is a clear sense, I think, in which within Asfeld, the wave function is not like pain, because the wave function is never understood as a piece of ontological furniture. So it's even if it's not fundamental, but still pain kind of exists, while the wave function really does not exist for Asfeld. So let's go to the second kind of way to interpret the wave function. We can think that the wave function is uninterpreted. We mentioned it's in the laws of nature, as I said before, but there is no meaning attached to it, okay? And this is, for instance, what Lewis was doing for chance. So what does it mean that there is a wave function in quantum mechanics, or that or in our system? It just means that there is a lawhood system, like our system of laws, which then turns out to be the best and where the wave function appears. Nothing more, nothing less. So when I see the wave function, it just means that in my laws of nature, there is something that we call the wave function. Then I would not understand if this is so why Aswell keeps talking about causal functional role and explanation. Okay. Also, we would not be able to say that the wave function is located or it's identical to the particle trajectories. We cannot say that the truth about the mosaic entails truth about the wave function, because the wave function is just an interpretive predicate. Also within Aswell's view, since not only the wave function, but everything that's not particle trajectories is should be uninterpreted, then we would have laws with too many uninterpreted predicates. Okay, so it seems that maybe Aswell has to get rid of the Humean approach, because within the Humean approach, it can't really make sense of this interrelation and interplay between functional role and identity and being unable to spell out this in terms of really particle trajectories and etc. So here we have been considering, I think, two different alternatives. So the first alternative, which was saying, look, the wave function is like a plane, and so it needs to be spelled out in terms of particle trajectories. What was doing? Well, it was rejecting the face value interpretation of the wave function and face value interpretation of sentences of the wave function. Why? Well, because every time we talk about wave function, we actually talk about trajectories, okay? But then these sentences were still true. Why they were still true? Well, because of course, when we say the wave function is such and it's an entangle and blah, 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 actually we are talking about particle trajectories, okay? But then the problem is that he needed a kind of method to paraphrasing sentences of the wave functions to in terms of particle trajectories, and this seemed to be not feasible. The second option would be to say, look, we can reject the face value interpretation of the wave function, again, and sentences on the wave function, but then saying that they do not have a semantic attached per se, which means they do not have meaning. So we don't know what actually wave function means, right? So we just, these are just uninterpreted mathematical symbols, which are there and are very powerful. So sentences still have meaning, but they probably inherit indirectly. And then but then the problem is that you have a system of uninterpreted claims, and it does not really make sense, you know, also to talk about like functional and identity and to say that the wave function is the particle trajectory, so it's not feasible. So this is where my third kind of option comes, and my proposal for Humeans, which is to accept the face value semantic of the wave function. When I say wave function, I just mean wave function, which is a complex valued field in a high dimensional space, or which is a vector Hilbert space, or a Hilbert vector. So we just mean what all mathematicians and physicists would mean by wave function, okay? So we don't need to paraphrase, okay? It's not uninterpreted, it has a semantics attached, but then I reject the truth of sentences expressing wave function. What does it mean? Well, it means that the sentences should still be interpreted as face value. So when I say the wave function is entangled and so on and so forth, then these sentences are just meaning what they mean, and so that we have entangled wave functions, but they should not be interpreted strictly expressing truth outside the dynamical structure. I'm not meaning that in the word we have a wave function, okay, that really has some particular entanglement structure. So what I'm proposing here, so the fictionalism has a kind of honorable tradition, and it's present in many different kinds of fields. For instance, in moral philosophy, philosophy of religions, in metaphysical, in mathematical philosophy, and etc. And normally, fictionalism is about the ontology. What does it mean? For instance, for philosophy of religion, we are fictionalist about God, so we pretend that God exists, but actually we know that it doesn't exist. With moral philosophy, we pretend that there are some moral values out there in the world, but we know that there are no absolute moral values out there in the world. For mathematics, we pretend that there exist some mathematical entities outside in the world, but actually we know that there are just some kind of computational devices that can be reduced to non-mathematical entities. And there is also a kind of fictionalist approach, I would say, that has been proposed. So Hartley Fields, in his book Science Without Numbers, really tries to develop this fictionalism for mathematics and say, look, all mathematical entities can be reduced to intrinsic relations of space-time regions. And then Eddie Chen really tries to do this for the wave function and tries to reformulate the wave function in terms of relations between different space-time regions. But then this is not good for Esfeld, because Chen then goes on to define the wave function as some kind of multi-fields, and so fields in our three-dimensional space which are non-local. But remember that the point for Humeanism is to get rid of non-locality. And to also remember that for Esfeld, that he would need to paraphrase everything in terms of particle trajectories, okay? So in order to make Esfeld's view more coherent and stronger, I think that we should not really stay in this kind of fictionalism for mathematical entities, but to shift our attention to the so-called Humean fictionalism, which was proposed by Achille Varzi in the context of metaphysics. So let's turn to Hume. Okay, Hume was a philosopher which was really motivated by empiricism, and he was saying, look, causation is a concept that does not correspond to a natural feature of reality. So there is nothing that we observe in reality which is causation. We just observe certain relation of succession, contiguity, and constant conjunction. And exactly, this is because we do not see causation, right? So this empiricism move. And the same is what Esfeld wants to do. So he says, we do not see the wave function, we only observe particle positions, okay? So the motivation that Esfeld gives is really this empiricism and this parsimony, okay? Which is a standard motivation for even many fictionalist accounts. Many fictionalist account starts by motivating their account with this empiricist and parsimony thing. So look, the proposal would be, well, we can literally interpret our laws of nature, their fictional structure using fictional entities. So we have a fictional wave function with some kind of entangled features, entanglement relations. And then these fictional entities can be more or less simple, they can be more or less fundamental, but within the realm of these fictional entities, okay? And then we do not really believe in the existence of this fictional entity. So the wave function is part of a fictional structure, which is our laws of nature, which does not reflect the structure of reality. And in this aspect, it's very clear, we should not take the Schrödinger equation to reflect the reality of our world, but rather helps us make sense of reality by structuring the scattered multitude of our empirical data. So we have the wave function because it helps us structure the multitude of our empirical data, the experiments data that we do. So pay attention, Humean fictionalism is not actually ontological, okay? Because the fiction concerned only this nomological and dynamical structure in terms of which we make sense of reality, like the Schrödinger equation. And this is the same scenario examined in Asphalt, which says, look, our laws of nature are ontologically insignificant, okay? And it's still compatible with some kind of metaphysical realism, because the Humean fictionalist says that we just should not confuse the structure the world is really is with the structure we pretend it has out of convenience, okay? And this is exactly what Asphalt does in his quantum Humeanism, because it's grounded in the primitive ontology program, okay? He borrows this primitive ontology program. And so he still has this kind of metaphysical realism according to which something out there exists. And so what really distinguishes this fictionalist stance is the emphasis that there is a difference between our structuring activity, and so our impulse to provide complex concepts like the wave functions through which we represent the world of experience, and then on the other hand, the nature of things and how they are. However, even though this fictionalist approach is not ontological, of course it has a direct impact on the ontology, right? Because if we reject the entities with which our laws of nature are written, then in the end we will have a very parsimonious ontology. And this is exactly the same strategy Asphalt can do for non-locality. So we have this kind of structuring activity, which is manifest in these entangled states of the system. But this is just our structuring activity to make sense of the particle trajectories, okay? But it's not in the particle trajectories. So now the question is not whether Asphalt will be happy with this Humean fictionalist stance. The question is whether there is room for such a stance within Asphalt Humeanism, and whether it makes it stronger and more robust. So is it really something that Asphalt can endorse? So these are the last slides. So, well, I just would like to say that I think that it has a good reasons to endorse this Humean fictionalist stance. Why? Because it preserves a local ontology, which was our initial problem. Okay, we do not have no locality in the world anymore. We do not have any modification of the mosaic, okay, because the mosaic is like the one Humeans have, and so we are still in the third group of solution we were saying we were looking at in the very beginning. Also, it avoids important problems like the challenge of paraphrasing the wave function, the fact that otherwise it would have uninterpreted predicates in the laws of nature, and etc. It's still compatible with some kind of metaphysical realism. Also, in many passages, Asphalt says that actually we have to wait until the end of the universe to actually attribute initial conditions of the wave function. And this might look very weird from a physical perspective, but it makes sense if we think that the wave function is just a fictional element of our reality. Of course, in order to know what kind of fictional entity is the best one, we have to wait until the end of space time in order to know what's really the best and what really is the best characterization of our world. Then it also explains why Asphalt keeps introducing this functional role to explain the particle ontology, because these fictional entities actually explain particles' motion and they create the best dynamical structure. But of course, there are problems with this view. First of all, we don't have anymore this kind of pure best system account according to which, as I said in the beginning, our laws of nature need to have some natural properties. And also, of course, now we have the problems that laws do not carve a nature at its joints anymore, okay? But then my response will be, well, but look, also within quantum Humeanism, we do not have this pure best system account, because, you know, even within quantum Humeanism, you have wave function, okay, which does not represent a natural property. Also, we can make sense of it because we can actually fix some predicates as a natural, and then, you know, we can formulate laws in that kind of natural language that we suppose and we postulate is kind of natural. And we still have a kind of best system account. We can still say that the laws are what is the simplest and the strongest account of our world. Then I think that, of course, it's terrible for scientific realism. We are losing scientific realism right now. That's true, that's an important cost, but I think it's less serious than it seems, because first of all, the incompatibility between the Humean fictionalist approach and scientific realism is not that serious, because of course we get rid of truth, which is the core of scientific realism, but we still have belief, because remember, like Hume never said that we do not believe in causation. Hume said, yes, of course we should believe in causation, but simply causation doesn't exist. So we can say, look, science gives us the most convincing and best structure we could ever have, an entangled wave function, okay? And then the structure we should believe in, an entangled wave function. But then we have to take it seriously only because it is the best fiction we could ever have, okay? And so because it would be irrational not to pretend that this is true, okay? And of course, this is still not in line with scientific realism. I want to emphasize this, but even Asfeld's account to quantum Humeanism is not really in line with scientific realism, because even in Asfeld's scientific realism, we do not have, you know, this kind of fundamental predicates in the laws of nature, and we have to say that, you know, wave function really doesn't exist, okay? And so I think that overall, even though we have to kind of give up scientific realism, we in any case make it more clear why also Asfeld actually gives has to give up scientific realism. So there is still some work to do, of course, because I have to still answer the question, why is it the laws are so efficient? If, you know, you have to kind of connect this fictionalist structure with the ontology if you want to make sense of why laws are efficient. But this, in any case, it's not something worse than in Asfeld's view, because also Asfeld has to make sense of how exactly the wave function and the trajectories are exactly related. And I don't know, this is a question for you, since you are all physicists. Like, do you think that my view probably makes more sense to scientific practice? Because I think that when probably physicists write psi, the wave function, then they really mean psi. They have a semantics attached to psi. They interpret it literally. Okay, so they're not thinking about particle trajectories. They think about psi. They believe in psi. Yet, I think they do not really believe necessarily in the existence of phi. You know, they don't go and start getting crazy like philosophers do. Like, oh, now we have in our ontology this so-called psi, this complex valued field. Okay. Also, probably, but I'm not sure, for you, statements about phi are true, sure, but within a quantum theory. Okay, not outside of quantum theory. We would not need to paraphrase anything with this fictionalist approach. And indeed, you physicists, you don't feel the need to paraphrase the wave function. And we take laws as the best tools for predictions and explanations, okay? And the terms in the laws are introduced functionally, sure, to account what we see and measure, but this functional approach does not lead us to think that the wave function is particle trajectories. And so overall, I would like to just wrap up and say, well, I kind of inquired into Asfeld quantum humanism, and I found some kind of challenges for him. I think I tried to make it precise with two different views, but I ended up with two not very coherent views. So I kind of proposed to understand Asfeld's quantum humanism as a form of Humean fictionalism, according to which our wave function is a fictional entity, part of a fictional structure, to account for our ontological reality. Of course, the cost is that we do not have scientific realism anymore, but I think that this would not make the Esfeld's view weaker. In any case, this would not be a disadvantage with regard to Esfeld's view. And so hopefully maybe it's in line with scientific, how scientists think about this thing. I would like to hear from you. So these are some references, but finally I would like to thank Michael Esfeld and the Lausanne group, like Dusty, like Zarovici, Federico, Benedict, Sandra Aldofredi, and Christian Lopez for really inspiring objections and questions they had. And especially thank you all for coming. And I look forward to answering your questions. Thank you so much.
I'm going to ask to unmute when you upload from this talk on, because it's weird not to hear. Thank you a lot, Vera. That was really cool. I already have a question. If you have questions, please raise your hands using the button. If you don't find the button, maybe just, either write in the chat or try and gesture, call me somehow. So first one is Alice, or Alice, I don't know, sorry. I don't know how to pronounce.
It's French anyway, so it's we don't have tonal change.
Alice.
So hi, thank you very much. It was very clear.
Thank you.
So I just have something that's still bothering me.
Yeah.
Is that I know that it's very common. It's a very common kind of epistemological opinion, like functionalism, constructivism, all these kinds of opinions. But still, I feel like, don't we owe something to the population? Like, especially right now, people are looking for explanations for the phenomenon. They want to know how the world is really, and also with all the quantum mysticism and everything, we should bring answers for that. And people are actually paying us to find these answers. So if we bring them, okay, we have fictions now. They will say okay, artists can do that too. I mean, don't we owe them something more?
Yeah. Yeah, thank you so much, Alice. This is a really interesting question. So what I think Quantum Humean would reply, or in any case, people working with this kind of approach, that they do not take laws of nature as ontologically significant, is to say, well, we are not saying that you cannot come up with a clear descriptions of the ontology and what exists. Indeed, they do. They use this primitive ontology approach. And so what they might say is, look, you just need to be empiricist until the very end of your day, and to be hardcore empiricist. So what you measure, then you have in your ontology. But what you really measure, you have it in your ontology. And so then, you construct and you give it to people who want to know what is real and what exists, simply a kind of descriptions of your empirical findings. Then, of course, I know that this is very naive, because in order to know what we are measuring, we need to know a theory. And in order to know, how to understand our theory, we need to know what we are actually measuring, and so on and so forth. So there is a kind of loop here. And for instance, primitive ontologists like Valia, probably they would say, look, all the things that you want to measure, like mass and charge and whatever, actually what you're measuring is particle trajectories, okay? And so this is why they really endorse this primitive ontology approach. And Michael grabs this kind of philosophical tool. And then probably what your laws of nature tells us about the world is just about some intrinsic feature of this particle trajectory. So how this, trajectories develop and etc. The problem and the irony is that for quantum mechanics, non-relativistic quantum mechanics, you will never be able to achieve this kind of construction, so this kind of knowledge, because of the uncertainty principle and etc. So yes, probably, I don't know, also I would like to hear from physicists, but probably this is also very kind of, it also really depends on what kind of physics are you doing. So for instance, if you're like an astrophysicist, probably you do not want to say that you come up with just the fictions. If you know you have to calculate with a meteorite, so will actually come to your Earth sooner or later. But I don't know about like you physicists who work on more kind of foundations of physics. How much realist are you about things like the wave function? Yeah.
So is it a question for me or just
Yeah,
in general?
yeah. I mean, I don't want to target you in particular,
So,
but yeah.
I guess I'm just still looking, but I'm not a physicist per se. I'm
I see.
more
Yeah, yeah.
working on philosophy of physics.
Yeah,
But
yeah. Yeah, thank you.
I guess I'll still be looking
Yeah.
for, you know, the something more than a fiction.
Yeah, yeah, yeah. Yeah, anyway, you can certainly say, look, physicists work and do research because they want to find what the world is like. I don't know, honestly, I don't know how many physicists think that this is their job. Maybe
Not many, very
exactly.
few in my experience.
Yeah, exactly.
I just know me and like a few others, but
Exactly, yeah.
yeah.
So yeah, I'm
Anyway.
in the same boat. Thank you very much for your question.
Thank you. So I have both a question from Valia and maybe a finger from Valia. So you can go whatever order, and then we will also hear from other physicists about what to think about the wave function.
Okay. Hi. Can you hear me? Hi.
Yes.
So thank you very much, Vera, for the great talk. I really like your approach. And so I wanted just to give you a suggestion personally. I think you're kind of overstating the problem regarding scientific realism. Because so if this is a view for S-field, this is going to work for S-field. If you're not a sort of primitive ontologist already, that's not gonna, I mean, as the previous question already pointed out, this is gonna give you not very much. If you wanna say, look, this is not going to explain. So if you're not already giving some reality already to something else, that's gonna do the, you know, what you observe, then to say, oh, the wave function is just fictional, then you do have the problem of scientific realism. You do have the problem of this fictional entity is not going to explain.
Mm-hmm.
But if you're like Hesfeld, right? And you say, look, what really exists is the primitive ontology, and that's the thing that you find in the word, then that's what you should be realist about. Mm-hmm. Right. And then you can be fictionalist about the wave function, right? Yeah. I think he will like it. Did you talk to him about that? Because I think he will love it.
Yeah.
I mean, I do love it. So, because,
so you see, Valia, but I don't understand, because I had a chat with Mikael. I didn't tell him about the fictionalist thing, but he was insisting on identity. So he criticized one of my papers because I didn't say that the wave function is identical to the particle trajectories. And but then if I talk about identity, then I cannot make sense of scientific realism.
Yes. Okay. I get it now. Okay. So yes, I am totally with you regarding that. I don't understand what he means by identity, because it's clearly, I mean, to me, it's clearly that they're two different things.
Yeah, exactly.
And so you cannot say, oh, the particle exists and the wave function doesn't, or it's another way of talking about the particles, because no, that's, I mean, I don't understand what he says. So, I mean, but it does make sense to me, what you are saying.
Yeah, and I even asked him, but so in your view, the wave function doesn't exist, because I had the primitive ontology program in mind like yours. But then he said, no, it exists, but it's located in the particle trajectories.
Fictionally so.
Yeah.
Right? Yeah, I mean, it's true. You can read off the wave function from the particle's trajectory. They wouldn't have that trajectory if it weren't for the wave function, which is a fictional entity that we use to describe the wave function. Yeah, I totally agree with that.
Okay.
But the identity relation is kind of misleading to me.
Yeah.
But just, thank you very much. I
thank
think you're
you.
right
Thank
on
you,
target.
Valia.
Yeah.
Thank you so much.
Now I'm going to shut up.
You don't have to. That was a cool exchange, actually. So Nicholas.
Yeah, okay, so me again. So thank you for this nice presentation. Actually, maybe the first one is not really a question, but maybe a comment, whatever. But so why do people in particular, Michael, talk about quantum humanism? This is Bohmian humanism. In quantum mechanics, particles have no trajectories. And here everything is based on these fictitious trajectories. So I think that the terminology is a bit misleading. And maybe the second, which is really a question. So you had this example for these trajectories in the two-slit experiment. So we have a single particle and it undergoes one of these trajectories according to Bohmian mechanics. But if I give you one of these trajectories, that doesn't determine one wave function.
Sorry, it doesn't?
It does not determine one wave function. If I just give you one trajectory, not the second.
No. So yeah, you have to take all the trajectories of all particles.
A single electron is not going to follow, according to Bohmian mechanics, all the trajectories. It only follows one of them. And if I give you one trajectory, that does not determine the wave function.
Yeah, so this is why Bohmians really talk about the universal wave function. So, and this is why they insist on talking about trajectories from the beginning of space-time until the end of space-time, because they hope that, in this way, you have, the whole picture. And in any case, even like in this double slit experiment, they would say, yes, we have the trajectory of the electron, but also the positions of, the particles of the experimental device and your own, trajectories that compose you and etc. So they always think it's better to talk in terms of this universal wave function and all the particle of the world from the beginning until the end. But yes, I definitely agree with you that, of course, Asfeld is a Bohmian, and so he actually has this way of responding because he's a Bohmian. But on his side, we have to say that without a kind of primitive ontology like trajectories, you cannot be a Humean and also endorse quantum mechanics. It's extremely difficult because a Humeanism already restricts you to a kind of like clear primitive ontology in terms of like point light particles and etc.
Another question. So at the very beginning, maybe the second of your slides, when I actually asked you, you had you mentioned non-locality and Bell inequalities or Bell theorems, but then never it appeared again in your presentation. So why is non-locality important in all that?
Because so the reason why we are developing this quantum Humeanism, what I call quantum Humean fictionalism, is to answer the particular questions of this incompatibility between quantum mechanics, where you have a non-locality, and the classical, the Humean picture. And then in the end, when I was talking about quantum Humean fictionalism, I was saying, well, then non-locality, it's like causation for Hume. So you should not really take it as something that really exists in the world. So it's a part of your fictional structure, the way you structure reality. And Bell's theorem for, I think, 90% of philosophers really tells you that there is non-locality in the world. So this is why I mentioned Bell's theorem in the very beginning.
But what you really use is non-separability and nothing more, or entanglement, as we say.
I see. So you have a different terminology for entanglement and non-locality?
Yes, because there exist entangled states, mixed entangled states that do not violate any Bell inequality.
I know that this is a really huge kind of incomprehension between philosophers and the physicists about Bell's inequality, and we interpret the Bell's theorem in very different ways, and also we name things like non-locality and non-separability in very different ways. So yeah, I need to really look into your literature to know exactly like what you mean by
You can
entanglement.
violate Bell inequality in classical mechanics, in Newtonian mechanics. You cannot do it in, okay, according to Newton's theory of universal gravity, you can violate Bell inequality with that. So you could now start to do a fictional human Newtonianism. Or no, whatever, Newton humanism. So I'm not sure I understand you, but anyway, thank you for your answers.
Yeah, thank you so much. Thanks.
I'm more optimistic that there is no such huge like incomprehension. I think it's just that it's true that like there are entangled states that do not that are not such that you can use them to violate inequalities. But as far as you just restrict the attention to those that do,
I see. I see.
In a way, you can, usually we say entanglement. Sometimes erroneously, we might say entanglement is the cause, but just because we are sort of saying the problematic part of the problematic set of entangled states, which are those that violate.
I see.
I don't think it's like a huge misunderstanding. Okay. There are worse misunderstanding than this one. I think.
No, I think that this is a pretty big one.
I wouldn't be too worried. So I have a question from Aurélien.
Okay, yeah. So thank you for your very interesting presentation about Humeanism. I didn't know so much about that before. Only David Hume. Okay, I read David Hume, but the fact that it's playing so much important in recent literature in philosophy of science is for me a bit surprised, because it looks like we are going back to something which is before the development of the determinism, because this is one of the questions that I have for you. It seems that the problem with for David Hume was the problem of the law of physics. So the law of physics is, and you mentioned it at the end of your presentation, you would like to have a kind of structure in space-time, let's say like some trajectory, and the law of physics will be something coming after for the ensemble of all the trajectory. So like it will not be necessary to use it, but simply to take the ensemble of all the trajectory, and then to say, okay, finally we can characterize them and say we have a law. But I found this a bit strange, because we use law of physics because they are very efficient and very. And when you say that the law don't exist, I'm surprised also, because the law should be. For me, they are existing because they are very practical tool in everyday life. So it looks like in a point of, if maybe I'm telling this wrong thing, but in a humanized view or in a fictionalist view, you would like to say that you have one universe, and then if you change the initial conditions, then maybe it will not work at all. But in physics, generally, we say we have law of physics which are valid and which are more fundamental than the initial conditions. Somehow you have to apply the initial conditions after that. So this is one of the question that I have. And the second question, which is more specific to your program, is the Brownian mechanic, because you say it several times. Estelle is advocating Brownian mechanic. I can understand it because I advocate also Brownian mechanics. So and I can understand also he said it's the best ontology. Maybe we even said it's the only ontology that we have in quantum mechanics. I'm more aggressive. But the problem is not that. The problem is that Bohmian people are not agreeing with each other. So they are conflicting all the time because some of them are thinking like Esfeld or Goldstein or Duhr or Brikmont that indeed it's nomological structure. The wave function is a nomological object. And some other people would say like David Bohm, or even Louis de Broglie, were thinking differently. And I think also more like these people, like this Bohm and de Broglie. Yeah. Because you see, to say that the wave function is only a law of physics is very strange for me, because wave particle duality seems to show some pictures. You say you need an explanation for it. You want to say that is a particle which is riding on top of a wave, like an intuition that you have a surfer on the sea. Yeah. So if it is true, then it means then the Bohmian mechanic ontology used by Esfeld is only a practical tool, but it's not the end of the story. And this is my perspective as a physicist. I cannot believe that the wave is so efficient for describing trajectory, and at the same time is not something more fundamental than simply a law. So yeah, that's a discussion that I think it would be interesting to
Yeah, thank you so much, Ariel, for sharing this. Well, I mean, concerning the first point, I also agree with you that it's a very unintuitive to really think that, you know, the laws of nature supervene on all the trajectories of particles and etc. I totally understand your view that you need laws of nature to predict, and that this is, you know, probably the most important thing for a physicist, right? So you need these laws to predict, and you get them and you take them as some kind of tools. Then when I say that the laws of nature don't really exist, I don't want to mean that they are not useful tools, okay? But just that they don't have their own, they don't exist in reality. So you don't have this kind of laws that really dictate you know, what, you know, the world will look like, but rather, as you said, yes, they are tools. So more kind of instrumentalist approach. And I do really share with you this concern. I mean, you mentioned about the initial conditions. So in Michael Esfeld's writing, it's clear that in order to know what the initial condition of the wave function are, you need to wait until the end of the universe, because it says the initial conditions of the wave function depend on the future trajectories of the particles. But this is extremely counterintuitive, because as you said, I mean, physicists normally need the initial conditions to know how to predict the future evolution. And so then, yeah, you know, if we have to wait until the end of time, then, you know, it would not be useful at all. But yeah, I think that here we always have to remember that probably it's, you know, like when philosophers are extremely precise. So for them, it's like, yes, you can kind of have already at, you know, certain before the end of your space-time, some kind of initial conditions, but you know, these are kind of tuned the more you progress in your history, because they are kind of representational devices. And then, you know, it's in order to know whether they are extremely effective and very precise, then, you know, you need to wait, you know, and see. So it's a kind of like reconstruction process. So at the end of the space-time, we can really know which are the very perfect kind of representational means that we have for our initial conditions. Then, yeah, I totally also agree with you that within Bohmian mechanics, you have wave function, realist like Bohm, who really thought about a wave field, as you said. So you were saying like surfing and etc. And so the people here in quantum Humeanism are really kind of endorsing this nomological approach to the wave function, which, as you said, it's very counterintuitive. But the problem is they want to make sense of of quantum Humeanism with the Bohmian mechanics, and you want to be really realist about the wave function. Then the problem is that you have to think that your mosaic is the wave function, and then everything else supervenes on your mosaic. And this is something that probably no physicist would ever think. So within a quantum Humeanism, probably the best way is to go for a nomological interpretation of the wave function. But I totally understand with you that, I mean, it's a very counterintuitive.
Mm-hmm. And maybe it's only formal because I don't know if we can decide. I mean, if you say that is a nomological structure, I can agree with that, because practically it will change nothing for my life of physicist. But you know, when I'm thinking about that, I'm thinking about Henri Poincaré, who was thinking about this kind of things already at the beginning of the 20th century, and he wrote something very important on that sense. He says, if you change the law of physics by adding variables, okay, as many as you want, you can call that superstructure if you want. You can add as many as you want, and you will not change anything to your ontology. At the end, if you have the same mathematical structure and you have some variable, you can say they are ontological, some they are nomological. If it's the same object, you will not change anything. So I'm wondering if it is not semantic only.
I didn't know about this quotation from Poincaré. This is fascinating. Yeah, so yeah, this really seems that yeah, you can add anything you want, but then your ontology is the same. And so yeah, the question is, what kind of semantics are this? You know, do this new elements and new variables have? And yeah, so if you are kind of like primitive ontologists, you will think, well, this just refer to particle trajectories. But yeah, then I mean, why do you need to add more and more and change? As you know, it's just to get your dynamical laws more efficient, or no, because sometimes you have to make some more predictive power. You have to make your laws and your theories more predictive.
Maybe the best system, as you said, to have the minimalist view.
Yeah.
Something like that. Okay.
Yeah, exactly.
Okay.
Yeah, thank you. Yeah.
Thank you for your talk.
Yeah, thanks.
Transferring.
Matteo, you're next. Sorry for waiting. And
yeah, no problem. Thank you very much. Hi, Vera. Thank you for the talk.
Matteo. Thank you.
I guess this is a sort of follow-up on Valia's question about realism. I have this doubt remaining after your talk. I mean, I'm not sure I see the conceptual space between Humeanism in general and Humean fictionalism. I mean, let me put it like this. I mean, it seems to me that in a sense, if you are a Humean, you are a fictionalist. So take Hume on causation, for example. Obviously, he's a realist about the things we see. Constant conjunction, regular repetition, contiguity in space and time, and so on. And then he says, well, this is my understanding, of course. And then he says, you can go on thinking as if causation exists. And if you want to be realist about something, you have to be realist about contiguity, regularity, repetition, and so on. What you cannot be realist about is necessity. There is no, well, as far as we can tell, there is no necessary link. And then you have to be a fictionalist about the necessary link.
Yeah.
So it seems to me that mutatis mutandis, this applies to you as well. I mean, yeah, it's true. Esfeld says identity, but it seems to me that the best way of understanding him is in terms of nothing over and above. So the wave function is like causation for Hume. It is nothing over and above these things, and we are realist about these things. Now, if this is correct, it seems to me that you're saying exactly the same thing.
Yeah.
Which is good for you because you can be realist about something. The
Yeah,
thing you're not realist about, no problem. For a Humean, I mean.
Yeah.
Yeah.
Yeah, so I mean, probably both, maybe both you and Valia are right. And so that my fictionalist attitude does not depart too much from Asfeld's Humeanism. Really, the problem is that I had a conversation with Asfeld, and he was really insisting first on the functionalist and identity relation. So he was really saying that, and also like at the specific question when I said, but you think that the wave function doesn't exist? And I said, no, I think that it exists, but it's located in the particle trajectories. And the way he, like in his papers, the way he frames this functionalism is, I think, really resembling David Lewis and Michael Jackson. And he also even like keeps quoting, sorry, Frank Jackson. Sorry.
Yeah.
And also David and Lewis. And so actually, I mean, they talk exactly about the very same thing for what? For pain. But then, I mean, pain exists, right? So pain, we feel pain. So pain is a physical state that we all have. And I don't know, it's not a parameter that you put in the law, like a dynamical parameter that you put in the law to, so I don't know, it seems to me that, I don't know. Yeah, I was a bit confused. I thought there was this tension within Asphalt. So one way to really think, yeah, the wave function exists is just reducible or identical to particle trajectories like pain to C fiber firing. But then on the other hand, he says things like, oh, the wave function is just a dynamical parameter. It makes the law stronger and simpler, and this is why we need it. And so it seems a kind of uninterpreted predicate like Lewis. So my answer is no, as well, just push this kind of fictionalist, kind of approach. Yeah, which would be much more in line with your Humeanism. Yeah, sorry.
I mean, I totally agree with your diagnosis. I agree with it so much that I think there is no other way of understanding Humeanism.
Yeah, good. Yeah. So then I'm grateful.
This is a metaphilosophical issue, of course, identity theory, nothing over and above talk. But I think the best way of understanding the underlying idea behind Humeanism in general is this.
Good.
X is identical to Y, which means that when I talk about X, I'm talking about Y.
I see.
So I'm an anti-realist about X because there is no X.
Yeah.
So causation, I'm a fictionalist about it because what I really mean is regularities and constant conjunction and contiguity and so on.
Yeah. Yeah. Well.
So,
Thank you so much for putting that in that way. Yeah. Yeah, because they also clarified, my problem with quantum Humeanism. Yeah, thank you. Thanks.
I'm still. I have one or two questions, so I'm going to ask them if there is no other people. I'm still like that's a very small point. I was thinking about this now. Why? I mean, it's weird to use pain C fiber as an example because they seem to be very distinct. So I was just wondering whether he uses other examples. So I mean, this case is one case where you have, I mean, people have argued that you have, they even argued for dualism, like Kripke has this paper where he talks about this, and he argues for realism, strong emergence, like autonomy, of the upper level. While in the case of whatever Asfeld wants to say of the wave function and the particle, it doesn't seem to be like strongly emergent. So I was just wondering whether he has a reason for taking this example, because it seems to me a bit sort of actually.
So he doesn't take this example. So he's mentioning, yeah, functionalism and identity by referring to Lewis and Jackson. But then these two talk expressively about pain. Okay. So when I then go to their work, then they are talking about pain. So this is why I brought them in my presentation. And yes, indeed. I mean, I think you raised an important point. So I think that the reason why we kind of bring up pain is to understand functionalism, but then you have a kind of, I mean, it depends on what kind of functionalism you have. And then, you know, you can be a kind of like reductionist and identity relational like Jackson, or then, you know, you can have a more kind of very strong emergent kind of pain, you know. Yeah, and everything really depends on your notion of functionalism and reductionism, what kind of, and it seems to me that Michael is really taking the view of reductionism as identity relation. And the, you know, and also Jackson and Asfeld really talks about this, sorry, Lewis talks about this in terms of functionalism. But yeah, it seems two different cases, right? The case of the wave function, which is just a dynamical parameter that figures in the law. It's not an entity, it's strictly speaking. And the pain, which it's a physical state. Yeah, thank you for
pointing. Yeah, was actually just, but I agree. I mean, it's definitely, I see why it's helpful to link it with functionalism, but I was just thinking in my
indeed.
For other reasons. So the other point was more like general and might be just naive, but I can't remember. I can't find exactly the paper actually. It's from Eddie Chan. So at least I'm going to mention rightly the person. So I think there is something like a critique to these views, like Asfeld, Perry, Bogle and Perry paper, which was something like the following. So I was wondering whether it applies to your views as well, and it seems to me that it does. So one of the worries one might have against this view is that, you know, it seems like it's I don't remember the exact word, but it should be something like cheap, in the sense that you can imagine whatever problematic ontology or whatever problematic relation in the world, like suppose tomorrow we discover through experiments or whatever that there is another very problematic relation, even more than entanglement, even more than non-separability, or you see what I mean? And and you know, I can always, it seems to me that I can always, you know, tell the fictionalist story, right? So it seems to me that what, you know, in part what Lewis was trying to tell us, look at the physics as far as it's not problematic, so don't look at quantum mechanics because it's problematic. Now it's missing because, you know, in the one end, with respect to, that was the philosophical papers, I think, the introduction. From then, which is the same year as aspect experiments on a locality, I think.
I see.
So that's also interesting. But like from them, you know, we progress with respect to the clarity of quantum mechanics. And on the other hand, we have, you know, even stronger reason that what he believed for thinking in the reality of those relations. So I was just wondering how far can we go, and you know, like in general, as a very general methodological.
No, I totally understand that this is a cheaper way to savor your theory, your Humeanism. And, you know, you just say, oh, but it's in the laws of nature. And what my fictionalist proposal would be, oh, but, you know, it's a fiction. Oh, it's a non-local fiction. It's a fiction. Of course, it cannot stay in your mosaic. And this really also probably it's a kind of criticism that you can move to super-Humeanism and in general to the primitive ontologist approach, which is, oh, then, you know, even like mass and charge and everything, you know, it's just not in our ontology. because we want to take an extremely parsimonious ontology, and so we explain it just putting in the dynamical nomological structure of the theory. Okay, so this is a kind of move that. So I think that so in the case of Humeanism is more problematic in the sense that for primitive ontologists, they start with a very clear manifesto. So they want a very parsimonious ontology, and they take seriously the claim that whatever you are measuring about in a system, you measure particle position. So that, it's a kind of postulate, even if you want, or a starting point in assumptions. And so that's fine, that's their assumption. But for Humeanism, as you said, it's very worrying, because Humeanism was born, as we saw the quote, as a kind of metaphysical position whose truth depend on the truth of physics. And so, of course, this of putting things in the nomological structure seems in a very ad hoc move. And yeah, I totally agree with this. This is a, it's a kind of ad hoc move. Yeah,
yeah, sorry.
Yeah, no, I mean, I read it, I wrote this very clear, I think, in one of my papers, and say, well, but I mean, you can do this for everything, and then this is not the point of Humeanism. Humeanism was born as a sort of naturalistic picture, but then I mean, this is certainly true, but then for like a chance. Then Louis was very happy to regard it as a kind of like interpreted. So yeah, I don't know.
But I want ciao Valia.
Thank you.
But I want to be clear that this was more towards this ciao Valia, towards the this general approach.
No, I totally agree with you. It's like 100%.
I have to agree with Matteo and Valia that this is so once you are there, then you're giving the best way to do it, which is already awesome. I mean, I wanted to be clear on this.
Yeah, no, thanks.
So we have time for a last point if it's not too huge. So Aurélien, please.
Just put the microphone. Sorry. No, it was mute. So sorry. Yeah, it was just a remark because you discussed before about parsimonious ontology, and even talk about this best system for the law. Okay, I can understand that, but in Bohmian mechanics you have non-locality, so it's a high price to pay. Because the Bohmian mechanics looks simple, so you have a nice ontology for describing the particle, for example. But in the same time, you have to assume non-locality. So you have no proof that you have not a better ontology where the locality would be restored, but then you will have to assume another principle. It would be maybe less interesting than non-locality in terms of, I don't know, efficiency, let's say. But it could be more efficient for justifying and explaining the world. No? Because when you say, this is very important because Bell theorem is not proving that the world is non-local. Bell theorem is proving that some of the assumptions that we have to use to describe the world with variables or with an ontology cannot be locality and pure causality. You have to break something. Either you break locality, then you have non-locality, or you can break causality. You have maybe, for example, you have super determinism or retro-causality, things like that. This is a different step. So you have no proof that the Bohmian mechanic is the best strategy. It's even though I found it elegant as a practical tool, my personal opinion is that it's only a temporary expedient. So yeah.
So sorry, because I didn't probably pin down what the question is. or yeah, so
most of remark about this parsimonious ontology stuff.
Yeah, exactly. Yeah. I mean, of course, like Bohmian mechanics is motivated by this clear and parsimonious kind of ontology, and of course, they have to bring inside non-locality because they are adding hidden variables to the theory, and so you need to, I mean, these hidden variables need to be non-local. So
again, it's not so elegant, you see, because it's non-local.
Yeah. I mean, you might think that's not so elegant, but yeah, I don't know. I mean, yes, I'm sorry because you know, I've always kind of studied and understood the Bell theorem as kind of saying, well, I mean, maybe we can get rid of non-locality by adding hidden variables. No, because even with the hidden variables, you get non-locality. So, but yeah, I'm not familiar about ways of.
What says the Bell theorem is that you start with some natural assumption from classical physics, like causality at the source and locality. Then you derive this inequality. And quantum mechanics is conflicting with this inequality.
Exactly.
So one of the assumptions has to be removed. And so the question is which assumption, and that's the problem.
Yeah.
So locality.
And so I thought that the assumption was really this local correlations. I mean, this the fact that, you know, your particles are already locally determined, that the properties of your particles are already locally determined. So I thought that this was the kind of assumption that.
Yeah, the thing is locally determined is part of the point of the reasoning, but the causality is also very important. It's a classical deduction that
I see.
Like genomes, genomics, propagation of information, things like that.
Yeah.
So,
But if I may jump in, Aurelian, it's just, you know, like I know that you are one of the few people, you can admit this, that still like superdeterminism. You can be honest.
I assume it.
But so let's leave superdeterminism aside for 1 second, just for the sake of the argument, please. Talking about violation of, you know, other ways to drop causality. It seems that this very same, you know, conclusions, meaning rejection or troubles with Humeanism, would appear in a different way. Because if you have, I guess, I'm wondering, if you have a retrocausality or if you have strong violation of the Reichenbach principles, stuff like that, it seems that, you know, you have the same problems, just that you're taking another path to get there. So I would say that it's true that, you know, if you look at the theorem, you know, you have to be specific about exactly how you get there. But then at the end, you know, the morale is, I would say, is very similar. For superdeterminism, I don't know, but probably there is a way in which you can be Humean easily about superdeterminism, but because you can do almost everything with superdeterminism.
Yeah, you're right.
That was a way of provoking you. Like
the simplicity of the world, you know, it's like a postulate that the simplicity of the world is always discussed, like if it will be natural to say what are the laws which are the most elegant or the most beautiful for, but this is a personal criteria. I think nature doesn't care so much about us and about if we think it's beautiful or not. And at the end, we have to see if the explanations is able to understand simply the universe. And it looks like, okay, you are completely right, maybe it's the same thing seen from the different perspective, but then it means that the parsimonious ontology or the best ontology for me is a bit arbitrary.
I see. Yeah.
It was my
Yeah, thanks.
Sorry that I jumped in, but if you
no, it helped a lot. Yeah, thanks.
So we're running late, so
thank you very much. Yeah, thanks for all the questions and comments and for hosting me today. Thank you very much.
Thank you for the talk. It was really great. I really liked it. And well, you're welcome to join for the next meeting. I have to say that there's going to be some discussion on similar topics later on, late April, beginning May, but I might be mistaken, with, among others, our own Matteo, who's there too. I think we will get, so it'd be nice to have you. And yeah, that's it. I'm going to thank you, everyone. I stopped the recording.